So this is basically the main part of the mini rock collar that I made. Basically what it is one drive shaft right here, one small miter gear, and a large miter gear, which is actually a double-sided one. And so it transfers power from, well, it transfers a rotational movement at a right angle. So the motor will power this axle, and the tires will be attached to either end of this one. So the motor will basically turn both tires at once, and I'll have this on both sides. I won't have steering because for something this small, steering isn't very good unless you have differentials. Here is the entire mini rock collar. I didn't make this solid so that it would actually have suspension. This isn't exactly normal suspension that you'd find on a car, but this is torsion suspension. So basically what it is the axles can turn at basically a really large angle to each other, so it can basically crawl over anything. So that's why it's called a rock crawler. So if you switch it on, it turns the motor on and basically starts turning the four wheels. It's a really slow vehicle, but it has a large amount of power, so it can basically crawl over anything. You can even make it crawl up a vertical wall. I mean, until it falls backwards, of course. Yeah, so you can see the suspension right now. So this is a model truck chassis that I built. I built this a really long time ago. Basically, I used kebab sticks to make a chassis, and I used them as the axles as well. And I used a few plastic gears and a motor. So the motor runs a gear to another gear that's attached to an axle that goes to the front and back. And there are two miter gears on each side, so they transfer rotational movement at a right angle. And there are two U-joints in the front so that the tires still spin even when the tires are turned. This wasn't a very good attempt, so I built another one, and this time the frame was plastic. I used a bunch of Lego pieces, and I also used sheet metal for leaf springs, and I used a lot more universal joints, and these universal joints are better too, and it worked a lot better. And the motor was really weak and fast, so it had a lot of stress put on the casing. So these are the individual parts of the robot base. There's a controller, there's a speed controller. This is a dual motor speed controller, so I can have tank drive. This is the receiver, the battery pack. I'll be changing that to a new one soon. These are the motors. They are a 50-to-1 ratio, so every time the actual motor spins 50 times, the tire will spin once. That's the base. I'm not going to be taking off this middle motor, and this is the armor. So this is my robot base. This is going to be for a battle bot, since me and my friends started a robot club at school, and I have been working on making this really short robot base moving around. I have 2 geared motors, some rubber compound foam tires, which will give me a lot more traction, and the whole base is solid steel. And I cut that out of just some random piece of metal I found. So I made my own battery case, which holds 10 rechargeable batteries. This top part, this motor in the middle is for the weapon, which will be basically body armor, and the whole top will spin. So I will have bolts attached to the top, so when the top spins, it'll be spinning at around 24,000 RPM. So when it spins, it will transfer all of the momentum into a hit, and basically the other robot will go flying. So if you turn this on, and you turn the controller on, you see the red light comes on. So it's got tank drive, which means that you can control the 2 sides separately, and that will let it drive around so it has 0 degrees turning. So here we have the top, which would be a solid aluminum cover with steel sides, and the steel sides are bolted into the aluminum top, and basically it can be bolted onto this motor mount. So that motor right there spins at 24,000 RPM. I'm not going to bolt it down right now because I'm not going to turn it on, because that would be quite dangerous at this time. So what would happen is the motor inside would spin the entire top, and these bolts on the side, which extend about a 1/4 inch out, would come and hit the other robot and transfer all of the momentum, as I said before. And that's basically it. So this is a, let's say, battle between my robot, which is on the left, and my friend's robot, which is on the right. I couldn't control my robot because I was taking the video, so nothing really happened during this battle. As you can see, we're both using spinning mechanisms as our weapons. I have a full body spinner, and my friend has an arm that spins on top. So as you can see right now, I've screwed in 2 blocks of wood so that I can mount the motors, and I've mounted the motors which have the tank wheels on them. So the whole thing is connected right now, and I'm going to run the first test. Okay, so I modified the wheel, made it tighter, so I'm going to retry this side again. I'm going to connect the wires. Okay, so we still have the problem of loose track, but this wheel spins fine. So now I have made a copper tube that goes across the top, and it is held in place by two plates that have been bolted on, and there are two idler wheels that keep the track taut. So this is my hovercraft that I made. I basically used a fan from a toy, and this motor right here and these two batteries right here are quite useless. I just use them as ballast weight to balance it out. So if you turn it on, you can see that it's floating on a cushion of air. So it inflates the bag underneath it with air because of the duct fan right there, and it's basically frictionless. So if you give it a little push, it'll basically slide around. I have yet to add a fan to it so I can make it go forward, and I also have to add a rudder to the back so I can steer. But that's basically it for the hovercraft. So this is the house that I built. This is my house, and I built a 1/15 scale architectural model of it. It's not completely finished, but so far it has most of the studs. I haven't built the inside rooms yet, but everything is as it should be right now. I'm going to motorize the doors and the garage doors, and I'm going to put glass in for the windows. So this is a model for a school that I worked on at an internship. Basically, we had to create a campus in New York City, and I created the mass model of it. So these are the classrooms right here, the cafeteria right here, gym and other sports rooms, the auditorium and entrance, and the football field right there. And over here are the other fields.